Hi, welcome to a video podcast on the diffraction grating. So a diffraction grating is a device that has many very small slits in it. And the bit confusing, the distance between the centres of the slits is now given by D. And to be honest, that number D gives more difficulty than almost any other number associated with this area of work. Because diffraction gratings often don't declare what D is. What they tell you is that maybe it's got 100 lines per millimetre. And you have to translate from that to find out what D is. So let's just work through that as an example. So if 1 millimetre, which is 10 to the minus 3 metres, is divided up into 100 parts, then each part is just 10 to the minus 5 metres. When we put light through a diffraction grating, what we would see is if the laser comes in, I'll just do the big picture before I zoom in, it hits the diffraction grating, and unlike the double slit, we're now getting very clear, well-defined dots on our screen. So if you imagine the rays going to these spots, we now use an angle theta to that spot, and we define these spots as orders. So this is the 0th order, 1st order and 2nd order. And we'll see that later that n represents the number of wavelengths path difference between adjacent slits. So we do need to be able to do a derivation of this. I think probably it'd be worth looking it up in the textbook because it is quite a hard thing to get the diagram really neat drawing by hand. But let's imagine that these two rays of light, which must make an angle theta if we're going to a bright spot, or off to a bright spot. So they look parallel, but they're eventually going to meet on the screen, but that's a long way away. This distance here, we've said, is D. And if we draw a line here at right angles to that line, this distance here is the extra distance that this line has travelled over this line when they meet. Now, we know for these waves to be in phase with these waves, this distance here must be a whole number of wavelengths. So it must be either 1 lambda, 2 lambda, 3 lambda. So this distance is n lambda. Last thing we've got to do is to try and find this angle theta. If we look at these angles here, we've got that this angle here is theta. That dotted line is right angles to the grating. So this angle in here is 90 minus theta, and that makes that angle there theta. So we've got a little triangle in there. I'm just going to draw it out again because I know it's difficult to pick out. We've got D, the distance between the two slits there. We've got that this side here is n lambda, and we've got that this angle is theta, and that's the hypotenuse. So sine theta is equal to opposite n lambda over hypotenuse D. So you get n lambda equals D sine theta, which is the diffraction grating equation. Applications for diffraction gratings, including using them to divide up the light from a star into a spectrum, and from that spectrum we get these characteristic lines, and the lines, absorption lines in starlight, are able to work out what elements are in a star.